Have you ever wondered about the most breathtaking wonders hidden within the Milky Way galaxy? From ancient stars to colossal stellar giants, our galactic home is full of marvels that defy imagination. What secrets does the Milky Way hold? And how do these celestial wonders shape the universe we live in? Join us as we uncover 7 of the most extraordinary wonders of the Milky Way galaxy, taking you on a mesmerizing journey through space and time. The Sagittarius Stream. Stretching like a ribbon across the vast expanse of the Milky Way, the Sagittarius Stream is a stunning example of cosmic dynamics at play. This incredible structure is a stellar stream composed of stars that were once part of the Sagittarius dwarf galaxy. Over billions of years, gravitational forces pulled the dwarf galaxy apart, leaving behind a trail of stars that now orbits the Milky Way in a spectacular arc. What makes the Sagittarius Stream so fascinating is its significance in understanding the history of galaxy formation. As the stars in the stream move around the Milky Way, they reveal clues about how our galaxy interacts with smaller satellite galaxies. Scientists study their distribution, speed, and composition to better understand the gravitational forces at play. The Sagittarius Stream is also a key piece in the puzzle of galactic cannibalism, a process where larger galaxies consume smaller ones. Observing this stream has helped astronomers confirm that the Milky Way has grown by merging with smaller galaxies over time. This discovery reshapes how we view our galactic history. Additionally, the stars in the Sagittarius Stream provide valuable insight into the chemical makeup of older galaxies. Many of these stars are rich in heavy elements, indicating that the Sagittarius dwarf galaxy underwent multiple generations of star formation before its integration into the Milky Way. The sheer scale of this structure is awe-inspiring, spanning nearly a third of the sky as seen from Earth. Its ethereal beauty and scientific importance make the Sagittarius Stream one of the true wonders of our galaxy, a testament to the ever-evolving nature of the cosmos. The Pillars of Creation. Deep within the Eagle Nebula, approximately 7,000 light-years from Earth, lies one of the most iconic sights in astronomy, the Pillars of Creation. These towering columns of gas and dust stretch several light-years high, resembling massive celestial sculptures. Yet these pillars are not static, they are active nurseries where new stars are born. The Pillars of Creation were made famous by the Hubble Space Telescope, which captured their majestic beauty in 1995. These towering structures are composed primarily of hydrogen gas, with dense regions collapsing under their own gravity to form new stars. The surrounding ultraviolet radiation from nearby massive stars sculpts and illuminates the pillars, giving them their striking appearance. Beyond their visual appeal, the Pillars of Creation are a rich source of scientific discovery. They offer a window into the complex processes of star formation. By studying the pillars, astronomers can better understand the life cycle of stars and the intricate interplay of forces that shape their birth and evolution. Interestingly, the Pillars of Creation may no longer exist as we see them today. Because light from this region takes thousands of years to reach us, it's possible that a supernova explosion has already destroyed the pillars. However, their image remains a powerful symbol of the ever-changing universe. These pillars are a reminder of the creative forces that drive the cosmos, illustrating the birth of new celestial objects amid the vast expanse of space. Their beauty and significance earn them a place among the Milky Way's most extraordinary wonders. Vy Canis Majoris. On the grand stage of the Milky Way, Vy Canis Majoris takes center stage as one of the largest stars ever discovered. This red hypergiant, located in the constellation Canis Major, is so massive that if placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. Vy Canis Majoris is nearing the end of its stellar life, and its enormous size is a prelude to its eventual fate, a supernova explosion. This star has already shed a significant portion of its mass, creating a surrounding nebula of gas and dust. Observing this phenomenon helps astronomers understand the final stages of massive star evolution. What sets Vy Canis Majoris apart is its unpredictability. Its surface is constantly in flux, with gigantic eruptions of material creating a chaotic and turbulent environment. These eruptions give scientists a glimpse into the complex processes occurring within the cores of massive stars. This colossal star is also a critical benchmark for understanding the upper limits of stellar sizes. Its existence challenges traditional models of star formation, and raises questions about the lifespan and behavior of hypergiants. Despite its distance from Earth, roughly 4,000 light-years, VI Canis Majoris inspires awe with its sheer scale and luminosity. It is a vivid reminder of the extremes that exist in our galaxy and a symbol of the incredible diversity of celestial phenomena. SIMS J031300.36-67839.3. Known as SM0313, this unassuming star holds a remarkable secret. It is one of the oldest stars ever discovered. Estimated to be over 13.6 billion years old, SM0313 formed just a few hundred million years after the Big Bang, making it a living fossil of the early universe. Located approximately 6,000 light-years from Earth, SM0313 has a composition that sets it apart from younger stars. It lacks heavy elements like iron, which are typically produced in the cores of stars and dispersed through supernova explosions. Instead, it is made almost entirely of hydrogen and helium, the primordial elements of the cosmos. Studying SM0313 provides scientists with a rare glimpse into the conditions of the early universe. Its existence confirms that the first stars formed shortly after the Big Bang, helping to seed the cosmos with the elements necessary for planets and life. This ancient star also challenges existing theories of star formation. Its low metallicity suggests that it formed in an environment with minimal chemical enrichment, a scenario that defies conventional models. Observing such a star opens new avenues for understanding how the earliest stars came into being. As a relic of the universe's infancy, SM0313 is a treasure trove of information. It stands as a testament to the enduring nature of stars and the vast timeline of cosmic history, earning its place among the Milky Way's greatest wonders. The Great Carina Nebula. Among the Milky Way's many stunning sights, the Great Carina Nebula stands out as a magnificent tapestry of stars, gas, and dust. Situated about 8,500 light-years from Earth in the constellation Carina, this vast nebula is one of the most active star-forming regions in our galaxy. Its immense size and brilliant displays make it a natural wonder of cosmic artistry. The Carina Nebula is home to some of the most massive and luminous stars known to science, including the enigmatic Eta Carinae. This massive binary star system is on the verge of a cataclysmic supernova explosion. Observing Eta Carinae and its surrounding nebula offers astronomers invaluable insights into the life cycles of the universe's most powerful stars. What sets the Carina Nebula apart is its remarkable diversity of celestial phenomena. Within its boundaries are towering pillars of gas, intricate filaments of dust, and newly formed stars. These structures are shaped by intense stellar winds and radiation, creating a dynamic environment that reflects the ongoing processes of star formation and destruction. Recent observations, including those from the James Webb Space Telescope, have revealed hidden details of the nebula's structure. By peering through dense clouds of dust, astronomers can witness the birth of stars and planetary systems, offering a glimpse into the origins of our own solar system. The sheer scale and beauty of the Carina Nebula make it a standout feature of the Milky Way. Stretching over 300 light-years, it is a cosmic masterpiece that embodies the creativity and chaos of the universe. Its glowing clouds and dynamic activity capture the imagination, earning it a place among the galaxy's most extraordinary wonders. The Fermi Bubbles. Towering above and below the Milky Way's central plane are the mysterious Fermi Bubbles, two massive lobes of high-energy gas stretching 25,000 light-years each. Discovered in 2010 by the Fermi Gamma Ray Space Telescope, these enigmatic structures are among the most puzzling phenomena in our galaxy. The origin of the Fermi bubbles is a subject of ongoing research. Scientists believe they were created by a powerful event at the galaxy's core, likely involving the supermassive black hole known as Sagittarius A*. This event may have been the result of a past outburst of activity such as the accretion of large amounts of matter or a burst of star formation. The Fermi bubbles are a treasure trove of data for astrophysicists. They emit high-energy gamma rays, providing clues about the extreme processes occurring in the heart of our galaxy. The edges of the bubbles are also sites of intense interaction between cosmic rays and interstellar gas, revealing the dynamic interplay of forces shaping the Milky Way. One of the most intriguing aspects of the Fermi bubbles is their symmetry. Their nearly identical shape and size suggest a single dramatic origin event. Studying these structures helps scientists refine models of galactic evolution and understand the long-term effects of energetic phenomena on a galaxy's environment. These colossal bubbles are a testament to the immense power of the Milky Way's core. Their discovery has opened new doors to understanding the past activities of our galaxy, making them one of its most awe-inspiring and mysterious wonders. The galactic halo. Encircling the visible disk of the Milky Way is the galactic halo, a vast, nearly invisible region that contains some of the oldest stars in the galaxy. Stretching tens of thousands of light-years above and below the galactic plane, the halo is a faint, enigmatic structure that holds the secrets of our galaxy's earliest days. The galactic halo is populated by ancient stars and globular clusters, dense groups of stars that orbit the Milky Way. Many of these stars formed more than 10 billion years ago, making them relics of the early universe. Their unique chemical compositions provide critical clues about the conditions that existed shortly after the Big Bang. What makes the halo particularly fascinating is its dark matter component. Scientists estimate that the majority of the halo's mass is composed of dark matter, an invisible substance that does not emit or absorb light, but exerts a gravitational influence. The halo's dark matter is crucial for understanding the Milky Way's structure and its rotation. Exploring the galactic halo also sheds light on the Milky Way's interactions with its surroundings. This region contains streams of stars torn from smaller galaxies that were absorbed by the Milky Way over billions of years. These stellar streams act as cosmic fossils, revealing the galaxy's history of growth through mergers and acquisitions. Though largely hidden from view, the galactic halo is an essential part of the Milky Way's identity. It connects the visible galaxy to the vast, unseen forces that shape the cosmos. Its mysteries continue to inspire astronomers, solidifying its place among the wonders of our galaxy. From towering star nurseries to colossal cosmic structures, the wonders of the Milky Way are as breathtaking as they are mysterious. Each reveals a unique story about the universe we call home. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the cosmos with us.
Did you know that most of the universe is invisible? Scientists believe an elusive force called dark matter shapes galaxies and influences the cosmos in ways we're only beginning to uncover. But what is it, and how do we know it's out there? From its strange properties to the mysteries it holds, dark matter continues to challenge our understanding of reality. Join us as we explore 10 fascinating things you need to know about dark matter, diving deep into the secrets of the unseen universe. Dark matter and the universe's composition. The universe is more mysterious than we ever imagined. While the stars, planets, and galaxies we see fill our night skies, they make up only about 5% of everything in existence. The rest is composed of dark matter and dark energy, which together account for an astonishing 95%. Dark matter alone constitutes roughly 27% of this cosmic makeup. This unseen substance doesn't emit light or energy, making it completely invisible to the naked eye and even to our most advanced telescopes. Despite its elusiveness, dark matter's presence is undeniable. It exerts a gravitational pull on visible matter, preventing galaxies from tearing apart as they spin. Observations of galaxy clusters and gravitational lensing, the bending of light caused by massive objects, offer compelling evidence of its existence. It's the silent architect of cosmic structure, influencing the formation and behavior of galaxies. Dark matter's discovery has been a game-changer in physics and astronomy. Fritz Zwicky first proposed its existence in the 1930s when he observed discrepancies in the Coma cluster's mass. Years later, Vera Rubin's work on galactic rotation curves provided further proof, showing that visible stars alone couldn't account for the gravitational forces at play. This discovery has sparked countless questions. If we can't see it or touch it, what is dark matter made of? Scientists are exploring exotic particles like WIMPs and axions as potential candidates. These investigations are driving groundbreaking research and reshaping our understanding of the universe's fundamental nature. Evidence from galactic rotation. Galaxies are cosmic wonders, but their movement poses a puzzle that only dark matter seems to solve. When astronomers study the rotation of galaxies, they find that the outer stars move just as fast as the inner ones, defying the laws of physics as we understand them. Without a massive amount of unseen matter, these galaxies should have flung themselves apart long ago. Vera Rubin's groundbreaking work in the 1970s provided key insights. She observed that the speed of stars in spiral galaxies didn't decrease with distance from the center, as predicted by Newtonian physics. Instead, the stars on the outskirts moved at nearly the same speed as those near the core. This phenomenon, called the flat rotation curve, pointed directly to the presence of a hidden mass surrounding galaxies. Scientists believe this mass forms a halo of dark matter, enveloping galaxies and holding them together through gravity. Without this invisible structure, the universe as we know it wouldn't exist. Dark matter not only stabilizes galaxies but also plays a critical role in their formation, influencing how stars and clusters come together over billions of years. The evidence for dark matter continues to grow through detailed observations and computer simulations. These models reveal how galaxies evolve, highlighting the essential role dark matter plays in shaping their structure. While the mystery remains unsolved, each discovery brings us closer to understanding this enigmatic force. The bullet cluster and direct proof. One of the most compelling pieces of evidence for dark matter comes from the bullet cluster, a collision of two galaxy clusters that occurred over hundreds of millions of years. This cosmic event has provided astronomers with a rare opportunity to observe the effects of dark matter in action. In this cluster, the visible matter, mostly hot gas, was separated from the dark matter during the collision. Using X-ray observations and gravitational lensing techniques, scientists were able to map the distribution of both. Remarkably, the lensing showed that most of the mass was concentrated in regions where no visible matter was present, aligning instead with the invisible dark matter. The bullet cluster serves as a cosmic laboratory, offering direct proof that dark matter exists and behaves differently from normal matter. Unlike gas and stars, which interact and slow down during collisions, dark matter passes through unimpeded, revealing its unique properties. This discovery has had profound implications for our understanding of the universe. It not only confirms dark matter's existence, but also challenges alternative theories that attempt to explain cosmic phenomena without it. The bullet cluster stands as a striking example of the unseen forces shaping our cosmos. Candidates for dark matter particles. Dark matter remains one of science's greatest mysteries, and uncovering its true nature is a top priority for physicists. Researchers have proposed various candidates for the particles that could make up dark matter, each offering unique possibilities and challenges. One leading contender is the WIMP, or weakly interacting massive particle. These theoretical particles interact only through gravity and the weak nuclear force, making them incredibly difficult to detect. Experiments around the world are searching for these elusive particles, using advanced detectors in underground labs designed to shield against background noise. Another intriguing possibility is the axion, a particle so light and weakly interacting that it's often compared to a ghost. Axions could solve several puzzles in particle physics, including the strong CP problem, while also accounting for dark matter. Innovative experiments are underway to detect these particles using specialized magnetic fields and radio waves. Some scientists are also exploring the idea of sterile neutrinos, a hypothetical type of neutrino that doesn't interact with normal matter. If proven to exist, sterile neutrinos could help explain dark matter's properties and its role in cosmic evolution. While no dark matter particle has been definitively detected, the search is pushing the boundaries of science and technology. Each experiment, whether successful or not, adds to our understanding and brings us closer to unveiling the true nature of the universe. Dark matter and gravitational lensing. One of the most fascinating ways we've detected dark matter is through the phenomenon of gravitational lensing. This effect occurs when massive objects like galaxy clusters bend the light from distant galaxies, acting like a cosmic magnifying glass. Gravitational lensing doesn't just help us see far-off galaxies, it also reveals the presence of hidden mass, dark matter. When astronomers observe lensing, they can calculate the mass of the lensing object based on how much the light bends. Often, the visible matter like stars and gas accounts for only a fraction of the mass required to produce the observed lensing. The rest is attributed to dark matter. This technique has allowed scientists to create detailed maps of dark matter distribution across the universe. What's truly incredible is how gravitational lensing provides a window into the past. The light we see has traveled billions of years, giving us a glimpse of the universe as it was when that light first began its journey. Through this lens we can trace the role of dark matter in forming galaxies and clusters over cosmic history. Gravitational lensing isn't just a tool for studying dark matter, it's also a reminder of the interconnectedness of the cosmos. The unseen mass that warps space and time continues to shape the universe, guiding the paths of light and the evolution of celestial structures. The role of dark matter in cosmic structure formation. The universe we see today, filled with galaxies, stars, and planets, wouldn't exist without dark matter. This invisible substance played a crucial role in the formation of cosmic structures after the Big Bang. In the early universe, tiny fluctuations in the density of matter created gravitational wells, and dark matter provided the necessary scaffolding for these structures to grow. Dark matter clumped together under its own gravity, forming vast cosmic webs that span the universe. These webs became the framework for galaxies and clusters to form, as visible matter was pulled into the dense regions created by dark matter. Without this invisible scaffolding, the universe would be a much emptier place. Simulations of the universe's evolution confirm dark matter's central role. When scientists run models with only visible matter, the results don't match the universe we observe today. But when dark matter is included, the simulations align perfectly, reproducing the large-scale structures we see in the cosmos. Understanding dark matter's role in cosmic structure formation not only explains the past but also helps us predict the future. As we map the universe and uncover more about its hidden components, we deepen our appreciation for the forces that have shaped everything we know. Dark matter and its interaction with normal matter. One of the most perplexing aspects of dark matter is how little it interacts with normal matter. While it exerts a gravitational influence, it doesn't emit, absorb, or reflect light, making it invisible and incredibly hard to detect. Scientists believe this non-interaction is key to its stability and longevity in the universe. Unlike normal matter, which interacts through electromagnetic weak and strong nuclear forces, dark matter seems to avoid all these interactions except gravity. This explains why dark matter doesn't clump together to form stars or planets like visible matter does. Instead, it remains distributed in massive halos around galaxies, influencing their rotation and structure. Despite its elusive nature, researchers are using ingenious methods to detect dark matter's subtle interactions. Detectors placed deep underground are searching for faint signals of dark matter particles colliding with atomic nuclei. While results so far have been inconclusive, each experiment refines our understanding and brings us closer to a breakthrough. The lack of direct interaction with normal matter is both a challenge and a clue. It suggests that dark matter could be composed of entirely new particles or forces, expanding the boundaries of physics and opening doors to unexplored realms of science. Theories and models of dark matters. Dark matter has inspired a wide range of theories, each attempting to explain its nature and origins. One of the most popular models involves WIMPs, or weakly interacting massive particles, which could be remnants from the early universe. These particles are predicted by extensions of the standard model of particle physics, such as supersymmetry. Another intriguing theory involves axions, hypothetical particles that could solve long-standing puzzles in quantum physics. Unlike WIMPs, axions are incredibly light and interact even less with normal matter, making them even harder to detect. Despite these challenges, experiments like ADMX are hunting for evidence of their existence. Some researchers propose that dark matter could be composed of primordial black holes, tiny black holes formed shortly after the Big Bang. These objects could mimic the effects of dark matter, though evidence for this theory remains scarce. Other models suggest exotic forms of matter such as sterile neutrinos or even entirely new dimensions of spacetime. Each theory pushes the boundaries of what we know, driving innovation in both science and technology. The search for dark matter isn't just about solving one mystery, it's about uncovering new laws of physics and redefining our understanding of the universe itself. Dark matter and dark energy, the cosmic connection. While dark matter makes up 27% of the universe, its mysterious counterpart, dark energy, constitutes a staggering 68%. Together, they dominate the cosmos, shaping its fate and evolution. Dark matter and dark energy are distinct yet interconnected forces that define the universe's large-scale behavior. Dark matter provides the gravitational pull needed to form galaxies and clusters, while dark energy exerts a repulsive force, driving the universe's accelerated expansion. This interplay creates a delicate balance, influencing the cosmos on both local and cosmic scales. Without dark matter's gravitational effects, dark energy might have torn apart galaxies long ago. Understanding the relationship between these two phenomena is one of the greatest challenges in modern physics. Observations from missions like the Wilkinson Microwave Anisotropy Probe and the Planck satellite have revealed how dark matter and dark energy shaped the early universe. But many questions remain unanswered. This cosmic connection reminds us of the universe's complexity and the limits of our knowledge. By unraveling the mysteries of dark matter and dark energy, we move closer to answering fundamental questions about the origins and ultimate fate of the cosmos. Future missions and the search for answers. The quest to understand dark matter continues to drive some of the most ambitious scientific missions. From deep space telescopes to underground detectors, researchers are exploring every avenue to uncover its secrets. Upcoming projects promise to revolutionize our understanding of this enigmatic force. The Vera C. Rubin Observatory, set to begin operations soon, will map the night sky in unprecedented detail, tracking the distribution of dark matter across billions of light-years. Meanwhile, experiments like Lux Zeppelin and Xenont are using cutting-edge technology to search for interactions between dark matter particles and normal matter. Space-based missions like the European Space Agency's Euclid telescope aim to study the effects of dark matter on cosmic structures, providing critical data about its distribution and behavior. These efforts, combined with advancements in particle physics, are bringing us closer than ever to solving the dark matter puzzle. The future of dark matter research is filled with promise and possibility. Each discovery adds a new piece to the puzzle, bringing us closer to understanding the invisible forces that shape our universe. The journey is far from over, and the best may still be yet to come. That concludes our journey into the mysteries of dark matter, an unseen force that holds the universe together and challenges our understanding of reality. From its role in shaping galaxies to the ongoing search for its true nature, dark matter is a testament to the wonders of science and discovery. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the universe's greatest mysteries with us. Have you ever wondered what would happen if the sun just vanished? No explosion, no warning, just gone in an instant. Sounds like something out of science fiction, right? But let's think about it. For 8 minutes everything would seem normal. Then, darkness, no sunrise, no warmth, just a world plunged into an eternal night. And that's only the beginning. Earth would break free from orbit, drifting into space. Temperatures would plummet, turning our planet into a frozen wasteland. Life would collapse, and humans, well, we'd have to fight against impossible odds to survive. So could we make it? Or would this be the beginning of the end? Let's find out. The first 8 minutes. Imagine this. One moment, the sun is shining, warming your skin, lighting up the sky, and then poof, it vanishes, just gone. No explosion, no warning. But here's the weird part, nothing changes. For 8 minutes and 20 seconds, Earth keeps spinning, birds keep flying, and the internet still works. Why? Because the sun's light and gravitational pull take time to reach us, exactly 8 minutes and 20 seconds at the speed of light. So, for that brief window, everything appears normal. The sun still looks like it's right there in the sky, but then, everything changes. Suddenly the world plunges into total darkness. No sunset, no twilight, just instant, all-consuming blackness. The sky, a gaping void, even the moon disappears because, guess what? It only shines by reflecting sunlight. And then gravity lets go. Earth has been locked in a gravitational dance with the sun for 4.5 billion years, but now, the music stops. No more central force holding us in orbit. We don't feel it, but at this exact moment our planet stops curving around the sun and shoots off into space, like a car suddenly skidding off a racetrack. But there's no panic, no alarms, no immediate disasters. For now, the only thing people notice is the pitch-black darkness, a night with no dawn. And in this eerie, unnatural silence, one terrifying thought starts creeping in. Something is very wrong. Earth breaks free. Imagine floating in space, untethered, weightless, completely free. Sounds peaceful, right? Now imagine Earth doing the same thing. But at 67,000 miles per hour. The moment the sun disappears, so does its gravitational pull. For over 4.5 billion years, the sun has held Earth in its invisible grip, keeping us locked in orbit like a cosmic leash. But now, that leash just snaps. At first, nothing feels different. You don't feel the planet moving, just like you don't feel it speeding through space right now. But make no mistake, Earth is now a runaway spaceship, no longer bound to its familiar orbit. Where do we go? Straight ahead. For billions of years we've been following a curved path around the sun, but with no sun pulling us in, we stop curving. Instead, we shoot off in a straight line, hurtling into the void. Imagine spinning a ball on a string, then suddenly cutting the string. That's us now. A lonely, frozen marble drifting deeper into space. The moon? It sticks with us, for now. Since Earth's gravity still exists, the moon keeps orbiting like nothing happened. But over time, without the sun stabilizing things, the moon's orbit could become chaotic. It might spiral closer, or drift away forever. And here's where it gets terrifying. As Earth speeds into the abyss, we leave behind something irreplaceable. The one thing that has always been our anchor. The solar system, our home, fades behind us. We are no longer part of it. We are alone. Instant darkness. Imagine flipping a switch and turning off the sun. 1 second it's bright and warm, the next? Total, absolute darkness. No sunset, no gradual dimming, just an instant void, swallowing the sky whole. The moon? Gone. It only shines because it reflects sunlight, so now it's just a dead, invisible rock drifting through space. The blue sky? It vanishes too. Without sunlight scattering through the atmosphere, our world is suddenly cloaked in an eerie, star-speckled blackness, even during what should have been midday. But here's the weird part, not everything goes dark immediately. For a few hours the outer planets, Jupiter, Saturn, Neptune, Uranus, will still glow faintly. Why? Because they were far enough away that the last rays of sunlight are still traveling toward them. It's like watching fireworks. After the explosion, you still see the light for a moment before it fades. And then there's Earth itself. Cities? They still glow with artificial lights, street lamps, neon signs, flickering TVs. But out in nature, everything feels unnatural. Even if you light a fire, it doesn't feel the same. Shadows don't stretch the way they used to. There's no golden warmth, no dawn on the horizon, and the stars, they look different. With no sun overpowering them, the night sky is now insanely bright. You'd see distant galaxies, nebulae, maybe even planets from other solar systems. A beautiful sight if it weren't for the chilling realization that this is it. This is forever. Earth becomes a giant freezer. Darkness is one thing. Cold? That's a whole different nightmare. Without the sun's warmth, Earth becomes a dying ember in space. The heat we once took for granted now slipping away, second by second. The first day? Not too bad. The temperature drops, but thanks to our atmosphere trapping some heat, it's still survivable. Maybe you grab an extra blanket, turn up the heater and think, this isn't so bad. But by the end of the first week, you step outside and feel a deathly chill, colder than the coldest Antarctic winter. The average global temperature has plunged to around -73 degrees Celsius, or -100 degrees Fahrenheit. The air bites. Your breath turns to frost the moment it leaves your mouth. Rivers freeze, lakes turn to solid ice. And the ocean? It's starting to freeze too. At first, only the surface forms a thick, glassy layer of ice. But below, the water remains liquid, for now. The deep ocean holds on to heat like a massive thermal battery, buying time before the inevitable. But time is running out. Within a year, the entire planet is a frozen wasteland. The surface temperature drops to -200 degrees Celsius, so cold that even the air itself begins to change. Oxygen and nitrogen start to liquefy, coating the ground in a thin, eerie layer of frozen gas. The sky? Empty, silent, lifeless. Earth is no longer a home. It's a drifting ice ball tumbling deeper into the void, and unless we find a way to escape, we're going down with it. The end of life. Life is resilient, but without the sun, it's on a ticking clock. Within days, plants start dying. No sunlight means no photosynthesis, the process that keeps them alive. First, the leaves wither, then the forests go silent. No buzzing insects, no rustling leaves, just stillness. A world that was once alive is now starving. Within weeks, the food chain collapses. Herbivores, deer, rabbits, even insects begin dying off. Predators hold out a little longer, scavenging whatever's left, but with every meal they're simply delaying the inevitable. Soon there's nothing left to hunt. Humans? We're resourceful, but this isn't just a food crisis. It's a fight against the cold. Even with stockpiled supplies, even in heated shelters, every breath outside freezes in your lungs. Cities turn into ghost towns, buried under layers of ice. Electricity grids fail, and slowly, one by one, fires burn out. But here's where things get strange. Not everything dies. Deep below Earth's surface, some life doesn't even notice the sun is gone. Creatures in hydrothermal vents, blind shrimp, bacteria, and deep sea worms, thrive in the scalding heat from the Earth's core. They don't need sunlight, they never did. Microbes living in deep caves, trapped under glaciers, or buried beneath the ocean floor, they could survive for centuries, maybe even longer. Earth's surface may be frozen solid, but underground, life still clings on. The real question is, how long can we? Could humans survive? Humans are survivors. We've conquered ice ages, deserts, and disasters. But could we survive the death of the sun? At first, yes. Governments would declare emergencies and people would retreat indoors using backup power, stockpiled food, and whatever warmth they could find. Underground bunkers, nuclear power plants, and geothermal energy sources would become humanity's last hope. But let's be real, this is just buying time. The biggest problem? Food. Without sunlight, crops die. Livestock starves. Canned goods and frozen food last for months, maybe years, but eventually supplies run out. Hydroponic farms and lab-grown meat could keep some people alive, but only for so long. A long-term food source? That's a problem no one can solve. Then there's the cold. Even with heating, temperatures outside drop below survivable levels. Oceans freeze, air becomes too thin to breathe, and every step outside is a death sentence. Cities crumble under the weight of ice. Power plants fail, and nuclear reactors eventually shut down. Maybe a few thousand people survive in deep underground shelters, heated by the Earth's core. Maybe they last centuries, using technology, rationing supplies, and clinging to life, but at some point, Earth will be too cold, too airless, too dead to sustain us. The only real hope? Leaving. But with no sun, space travel is nearly impossible. No gravity assist, no energy source, no safe destination. Earth was always our home, but without the sun, it's just our tomb. So what do you think? Could humanity survive without the sun, or would Earth become a lifeless, frozen rock drifting through space? One thing's for sure, we owe everything to our star. If you enjoyed this mind-bending scenario, make sure to like, share, and subscribe to InnoVision Tech for more fascinating science and technology explorations. Got a wild what-if question? Drop it in the comments, we might cover it next. Until then, stay curious, stay innovative, and keep exploring the unknown. Hey, welcome back to InnoVision Tech. Have you ever imagined a robot that isn't just made of metal and wires, but also living tissue? What if machines could move, heal, and adapt just like humans? It sounds like something from a sci-fi movie, right? Well, biohybrid robots are making that a reality. Today we're diving into the fascinating world where biology meets robotics. So, what could these biohybrids mean for the future? Let's find out! What are biohybrids? Hey, innovators! Have you ever imagined a world where robots aren't just machines, but living creatures made from biology and technology? Sounds like something straight out of a sci-fi movie, right? But here's the crazy part. Biohybrid robots are already being developed today, combining living tissues with synthetic components to create machines that can move, heal, and adapt just like living organisms. It's not just the future, it's happening now. Biohybrids are the fusion of biology and robotics, opening up possibilities that were once unimaginable. Imagine robots that can regenerate like humans or move with fluidity that traditional machines just can't match. This incredible technology is merging the best of both worlds, biology's resilience and robotics' precision, creating something entirely new. So, why is this such a big deal? Because biohybrids could change everything. They could revolutionize industries like medicine, environmental monitoring, and even space exploration. The real question is, are we ready for this new frontier where life and technology meet? Let's dive into the science and see what makes biohybrids so unique, and why they might just be the future of robotics. Stay tuned as we explore how living cells can give robots a whole new level of intelligence and adaptability. The science behind biohybrids. Now let's get into the science. So, how does a robot get alive in the first place? Well, biohybrids are all about combining living cells with synthetic materials, and it's more than just cool technology. It's a whole new way of thinking about machines. Researchers are using muscle cells, often taken from animals, and combining them with soft robotics. These muscle cells are cultured in labs and then attached to robotic structures made of flexible materials like silicone or hydrogel. The living cells contract and expand, much like our own muscles do, which gives the robots the ability to move. It's a completely different approach from traditional robots, which rely on motors and gears to perform tasks. The result? A robot that can move more like a living creature, smooth, flexible, and much more efficient in tasks that require delicate, human-like movements. Some biohybrids can even adapt to changes in their environment, respond to stimuli like light and touch, and heal themselves when damaged, something that's never been possible with purely mechanical robots. In short, biohybrids are bridging the gap between the biological world and the robotic one, and we're only scratching the surface of what they could do. Imagine robots that learn, heal, and adapt in real time. This is the future of robotics, and it's happening right now. Real-world applications. Alright, now that we know how biohybrids work, let's talk about how they can actually change our world. These robots aren't just theoretical, they're already making waves in several fields, and their potential is limitless. Take healthcare, for example. Imagine a robot that isn't just a machine, but one that can assist with surgeries or rehabilitation by moving just like a human. Biohybrids powered by living muscle tissue could be used in surgeries that require a delicate touch, offering flexibility and precision that traditional robots simply can't match. They could help doctors perform complex procedures with enhanced dexterity, or even assist patients in their recovery by mimicking human movements for physical therapy. But it doesn't stop there. Biohybrids could also revolutionize environmental monitoring. These robots could navigate through harsh and dangerous environments, places that are too risky for humans or traditional machines. Whether it's exploring the deep ocean, trekking through dense forests, or even venturing into outer space, biohybrids could become our eyes and ears in places we'd otherwise never reach. And since they're part biological, they can adapt in ways that purely mechanical robots simply can't. Biohybrids could evolve to survive in changing conditions, making them incredibly useful for long-term missions in extreme environments. It's clear, biohybrids are the future of robotics, with practical applications that can transform industries and change the way we live. Ethical considerations. As exciting as biohybrids are, they come with some serious ethical questions that we need to address. After all, we're not just talking about creating more advanced robots. We're talking about merging biology with machines, blurring the line between life and artificial intelligence. So, let's dive into the big questions. Should biohybrids have rights? What happens when a robot powered by living cells starts to act and respond in ways that resemble life? It's a tricky question, and one that scientists, ethicists, and lawmakers are already grappling with. If these robots can heal themselves, adapt, and perhaps even learn from their surroundings, does that make them more than just machines? Should we treat them as living organisms with their own rights, or should they remain under human control? It's not just about the robots themselves, but about how we, as a society, use them. If biohybrids are designed for medical applications, could they be used to replace human workers in critical care or surgery? How do we ensure that their creation and use don't harm people or the environment? And what about the implications for the workforce? As robots become more advanced, what happens to human jobs? These are important questions that need to be addressed as the field of biohybrid robotics moves forward. It's up to us to establish ethical guidelines that ensure these technologies are used responsibly, balancing the incredible potential with the need for safeguards. The line between life and technology is becoming more blurred, and the ethical implications are as vast as the potential for innovation. The future of biohybrids. So, what's next for biohybrids? Well, the future is incredibly exciting. Imagine robots that not only perform tasks with precision, but also think, feel, and interact with the world in ways that mimic living organisms. Biohybrids could eventually have the ability to sense their environment, adapt to it, and even evolve over time. It's like giving a robot a brain and body that can grow, heal, and learn. Think about robots in space. Biohybrids could become the ultimate companions for astronauts on long-term missions. These robots could adapt to the harsh conditions of space, repair themselves if damaged, and even assist in tasks like navigation, research, or habitat construction. Since they're partly biological, they could evolve to survive in the extreme environments of distant planets or moons. And on Earth, biohybrids could be the key to solving environmental challenges. Imagine robots designed to help clean up polluted areas, using their biological components to adapt and heal, functioning continuously without the need for constant human intervention. In medicine, we could see biohybrid robots that can assist with patient care on a much deeper level. Instead of just performing tasks, they could become empathetic companions, understanding human emotions and needs. These robots might one day be capable of delivering personalized healthcare, understanding a patient's condition by feeling their responses, and acting accordingly. The potential applications are truly limitless, and we're just beginning to scratch the surface. With advancements in tissue engineering, artificial intelligence, and robotics, the possibilities for biohybrids could redefine the way we live, work, and interact with machines. In the near future, we might not just be relying on robots to help us, we might be living side by side with them, creating a harmonious blend of biology and technology that enhances both our lives and theirs. The line between the artificial and the living is disappearing, and it's up to us to shape this exciting future. Thanks for tuning in to InnoVision Tech. Biohybrid robots are just the beginning of a whole new era where biology and technology converge. What do you think? Are we ready for machines that can heal and adapt like living organisms? Drop your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell so you never miss an update on the latest in science and tech. See you in the next video.